Grade 7, this is a math video for lesson 11-8. The first thing I need you to be aware of is this table. I would highly suggest you write this down somewhere. I don't even care if you write it in your book at lesson 11-8. I'd also recommend you write it at the top of the assignment that you're about to do, worksheet 11-8, because this will help you considerably to wade through what we're about to do. When you see this sign, less than or equals, you're going to be using a solid line and you're going to be shading below. I know this doesn't make sense now, but it will in a few minutes. When you see this sign, you're going to make a dotted line and shade below. Do you see the connection? Less than is always shading below. Greater than is always shading above. With the greater than symbol, you use the dotted line. With a greater than or equal symbol, use a solid line. Okay, now, how do we use this in a situation? Here's my first equation. Y is greater than, that's not a y. Y is greater than x minus 6. First of all, temporarily, just imagine that's an equal sign, and imagine, is that in slope-intercept form if I made it an equal sign? And the answer is no. I do have a slope here of 1, but I need to change this to adding a negative 6. Okay, so that's the first thing I'm thinking about. The second thing I'm thinking about is if I'm going to graph this on a quartered plane, my first dot has to go at negative 6. Just like we talked about in previous assignments. Where's my second dot going to go? Well, the slope is 1. A slope of 1 can be thought of as 1 over 1. So I rise 1 and run 1. Bump, bump, bump. I put my next dot right there. And we have a line that looks like this. Now, greater than symbol. Let's look at the chart. With greater than, we use a dotted line and we shade above. So watch what I'm going to do. I'm going to make this line a dotted line, and I'm going to shade above it. Now you might be wondering, what in the world does this all mean? Here's what it means. If I pick any spot in this shaded area, it doesn't matter which, any spot in this shaded area, I'm going to pick location 0, 0. And I take that location of 0, 0, and I put it into this inequality. Watch what I do. I'm going to put a 0 here. I'm going to put a 0 here. Guess what? 0 is greater than this. This is negative 6. When you do all the calculating, 0 is greater than negative 6. So anything in the shaded area works for this problem. But what if I chose something over here that's not in the shaded area? What if I chose, say, positive 3, negative 6? Positive 3, negative 6. That would be right there. It's not in the shaded area. If I put a positive 3 here and the negative 6 here, because the negative 6 is the y value and the 3 is the x value, this is not a true statement. Negative 6 is not greater than negative 3, which is what that equals. So this is the graphing of the equation that we originally had up here. I'll show it again. It's going to be y is greater than x minus 6. Okay? Let's try a different one. How about y is less than or equals to 2x plus 2. 2x plus 2. Yep, let's do it. First of all, look at the symbol. Look over here. With that symbol, I'm going to end up with a solid line, and I'm going to end up shading below. So let's keep that in mind. Where do I put my first dot? No biggie. I've got slope-intercept form here. If I think of this as an equal sign, this is my slope, and this is my y-intercept. Remember, slope-intercept looks like this, right? So I put my first dot at location 2, because 2 is my y-intercept. My slope is 2, so we think of slope as being a rise of 2 over a run of 1. So I'm going to go up 2, and I'm going to go over 1, and I'm going to put a second dot there. There's my slope of 2. Then I'm going to draw my line. And because of the rule over here, I'm going to use a solid line, and I'm going to shade below. Use a solid line, and I'm going to shade below. This is the solution to this problem, shading below. Let's try another one. Let's try a problem like this. Y equals, oh, I'm sorry, it's not equals. Y is less than, how about 3x plus 1. 3x plus 1. Let's try that one. Okay, where's my first dot going to be? Well, if I think about this as being in slope-intercept form, y equals mx plus b, there is a plus sign there, so plus 1. I put my first dot at plus 1. First dot at plus 1. My slope is 3, so I think about 3 as 3 over 1, a rise of 3, and a run of 1. Puts me a second dot there. I put a line here. Now I look at this symbol, and I look at my chart. My chart says with that particular symbol, the less than symbol, I'm going to use a dotted line, and I'm going to shade below. Whoops, wrong side. I'm shading below, and I got to use a dotted line. There's my graphing of this inequality. Dotted line, shading below. Let's try another one. Let's try something like this. Y is greater than or equals negative 2x minus 1. Is that in slope-intercept form? No, it's not. Why not? Because it has a subtraction sign instead of an adding sign. So I need to change this to adding a negative 1, which means that my first dot is going to go at negative 1 on the y-axis. My slope is negative 2, so I want to think of that as negative 2 over 1. So I am going to rise a negative 2, which means dropping negative 2, and I'm going to run 1. That puts me right there. I'm going to draw my line, and then I got to go look at the chart. Greater than or equals to, greater than or equals to, solid line, shade above, solid line, shade above. I already got the solid line, and here's my shading above. I am done with the graphing of that line. Let's try another one. How about y is greater than 3x plus 2? Does that look like slope-intercept form other than the equal sign? Yeah, it does. So where am I going to put my first dot in this? My y-intercept is positive 2. So there's my first dot at positive 2 on the y-axis. And my second dot, oh, my slope is 3, so I think of that as 3 over run. I'm going to rise 3, and I'm going to run 1, and I'm going to put my next dot there. Let's get rid of this so it's out of the way. What kind of line should it be? Should it be solid or dashed? That says that we should use a dotted line, and we should shade above. So dotted line. And we're going to shade above the line. And we are done with that particular problem. We are done with that particular problem. Let's try another one. What if I have something like y is greater than negative 2x minus 2. Y is greater than y is less than, y is less than negative 2x minus 2. Uh-oh, first thing I notice, that's not in slope-intercept form. I've got to change that to adding a negative. But after that, where do we put our first dot? We put our first dot at negative 2 on the y-axis, right? So there's our first dot. And this is our slope, -2. So I'm going to think about it as rising a -2 and running 1. Rising a -2 is actually dropping 2. So I drop 2, run 1, and I put my line right here. Okay, that's a less than symbol. Let's go over here. Less than is a dotted line, and we're going to shade below. Dotted line, shade below. So I dot this, and we're going to shade below the line. Okay, hopefully this helps you, folks. Remember, this table, very important. You better be writing it down in maybe more than one place so that it's helpful to you to solve these problems.